really want to be there, but apologies, I cannot because of visa issues. I will be available, however, online for the next 2 days to help with your project. Feel free to book time with me or telegram me or send me messages, direct messages to resolve your issues related to integrating our technology. Now, by now, if the program has gone to plan, you might have heard from Avalanche, Avalab, I believe, Solana project, and also Polygon. I met Manny, if Manny was speaking. I met Manny over in Lisbon last month when we were at Web Summit. So great man. He must have talked a lot about Polygon to you. So Avalanche, Solana, Polygon, they all have wonderful infrastructure they have provided for Web3 for developers, and for blockchain industry overall. Today, my talk, Decentralize Your Application Storage with IPFS and Filecoin, is going to focus on storage and storage only. Now, it is talking about file systems, but I promise you it is going to be the coolest file system you will ever hear, and it's not going to be boring, because what we're going to talk about is Web3, what it is in general, peer-to-peer computing, immutable content through IPFS, long-term storage through Filecoin, and I will show you many use cases of the technology that Filecoin and IPFS have built, and I'll show you some code. This is developer bootcamp after all. I'll show you some programs that I have made to demonstrate how easy it is to integrate IPFS into your project. So let's get started. It is a cliche to start the talk with someone's quote, but I'm going to do that anyway. So the original idea of the web was that it should be collaborative space where you can communicate through sharing information. So Sir Tim Berners-Lee is recognized as the inventor of the expression and the concept of web. So our internet have gone through some evolution over time. When it was invented the first time, it was just for the communication of a few computers. Files gets transferred, and then chat or messages gets transferred over the wires, and that was exciting for people. Quickly, people discover a really useful use case of the internet, which is hosting content on servers and allow other people to read it. There is a huge benefit to putting it on the computer rather than putting it on the book, is that you can check the references, namely the hyperlinks, very quickly, very easily. So Web 1.0, when it was used, when it started to explode, it was mainly for normal people to consume information. And then quickly, the internet has evolved into what we have right now. We saw the rise of content platforms like Facebook, LinkedIn, and Twitter. So these platforms allows normal people like you and I. We are not system maintainers, we're not server maintainers, but we are able to use the tools that they have created to be able to create content every day very easily. So they're democratizing content creation for us, and they're hosting a lot of internet information for us. But we're relying on the trust of these big companies to be able to make it function. And if they go down, if they fold, or if they stop providing services, it will impact us greatly and our content will perish. So a lot of smart people got together and thought that was not cool, so they have invented the idea of Web3. It is the internet that you can read and write, but also it is the internet that you can trust, because there's no centralized enterprises controlling certain functions. So the word, so in short, the web is going through decentralization because of the problems that centralization has caused, like single point of failure. We have heard of data breaches. We have heard of Amazon Web Services. We have heard of big companies are losing trust because they're misusing users' data. And there are a lot of data monoliths that's been created by centralization because everyone tries to keep a copy of the internet themselves. So like a picture on Facebook, it doesn't automatically show up on Flickr or other places. It creates a lot of duplication of data on the internet. It's actually incredibly inefficient right now. So when we load a picture from Facebook, when we load a picture from Flickr, we're downloading it quite a few times where it could be just available nearby. So a lot of people have realized the centralized problem. Even the centralized companies have realized those problems. So they're distributing their service all around the world to decentralize the risk. And then eventually what a lot of people predict that will happen was that the internet will evolve into this distributed version called Web3, and is where users sort of help each other to provide services. It is censorship resistant, and it has a huge big privacy feature to it, and then there's no siloed data. The best explanation of Web3 I came across is from Protocol Labs engineers. So they describe Web3 as a combination of distributed web, so web that is able to work offline, faster, safer, and there's no central coordination. And there's a concept of permanent link, so your content shouldn't disappear. The link to the content shouldn't be stopped working just because the service is not available. It should always be there. So that's the distributed web. And it should also has this blockchain functionality in it, because blockchain distributes the ownership, distributes the governance of a project, so you don't have central organizations to control vital resources on the internet. So it allows people to have publicly verifiable records, allows people to come in, participate in the network, and then go out whenever they like. So you can quit the thing if you want to, and it has incentive to allow people to do the right things, and it will punish foul players in the network. And lastly, there's the concept of semantic web, so the smarter web or smarter graph of knowledge on the web, where all the objects are has a meaning, and the programs understand the meaning of it. So for example, Taipei is a city, and it's only one in the world. It shouldn't be kept. There should be just one object on the internet about Taipei, this city, and there shouldn't be tens of thousands of copies of it lying around in the internet about it. So before I go further, I'll need to explain a couple of organizations and a couple of technologies. So Protocol Labs is a open source R&D lab building the fundamental building blocks for Web3. So that's protocols, tools, and services. They want to upgrade the internet. And so they have also helped funded the Filecoin Foundation, and Filecoin Foundation is leading the Filecoin community to put the power of humanity's most important information back to the hands of everyone. So these are two organizations working very hard to advance the agenda of Web3, and how they do that is actually through two very important products in Web3 right now. One is IPFS, and the other one is Filecoin. IPFS is a peer-to-peer protocol. It is a protocol, so a way for computer to talk to each other, and it is trying to make the web better by making it upgradable, resilient, and more open. Think of it as the Web3 version or peer-to-peer version of HTTP. And then Filecoin network is a decentralized storage network to store humanity's most important information. So think of it as a Airbnb for data storage or hard drives. People are trading hard drive spaces on Filecoin network marketplace right now. There are not just one IPFS or Filecoin product that Protocol Labs have started. Protocol Labs starts and supports a lot of computing projects. One of the coolest, I think, is a DRAN on the right bottom right corner there. DRAN intends to provide randomness or random number generators through distributed computing. Is one of the best that's been recommended by many cryptographers in the industry. There is also libp2p, which is a peer-to-peer network protocol. You can use peer-to-peer to build many applications like peer-to-peer chat, peer-to-peer file sharing application protocol, peer-to-peer streaming if you want to, and those things will not require a centralized server. So it has a lot of technologies that is able to allow things like browser-to-browser communication really happen without the need of intermediary server. So there's a lot of good stuff that Protocol Labs is working on. Now, where does IPFS and Filecoin fit in? As I mentioned, Solana Avalanche, and Polygon all focus on quite specific, and also they cover a lot of areas these days. But where IPFS and Filecoin fit in is actually very specifically for file storage. Because file storage is a very important feature of the computing system, it is also a very important function of the internet. So everything, just about everything we interact with, the slide that I'm using today, it needs to be stored on somewhere, on someone's computer to be able to serve. So we're trying to solve that problem in a very different approach, in a very distributed way, in a very Web3 way. So let's get into the details of IPFS, what it is, what exactly it is. IPFS stands for Interplanetary File System. IPFS is one of my favorite acronyms in Web3 because it's one of the coolest. It is a file system, so it has files and folders. That's it. And then it is interplanetary because it's distributed, born distributed. There's no central server in it. It is resilient and offline first. And the reason why it is called interplanetary is because the problem of communicating between planets, sharing files between planets, is actually best solved by a distributed computing system. Let's imagine we need to keep a copy of internet on Mars for whatever reasons, and IPFS is best suited to be able to do that job. IPFS works by a technology called CID, or Content ID. Now, it is trying to fundamentally change the way we interact with the internet by using something called content-based addressing. Now, content-based addressing systems, they do not refer to systems, do not refer to content by where it is, but we refer to it by what it is. So the current internet, when we interact with it, when we type in a domain like google.com, it will translate behind the scenes into IP addresses plus port, and that points to a specific server. So intrinsically, it's like client-server model. It will find the location of the server and the file and try to serve it. When the file is not there, when the server is down, or when the developer forgot to pay a monthly bill that they have, the server that they have rented, the file is not available to the users. However, for IPFS, it keeps a cryptographic hash function or digest of the content itself. So the file itself is turned into digest, and then this ID is used as for routing. So it's the new URL of the internet. It naturally contains the information about what content it is. So it does it by using the technology of CID. This is what a CID looks like. So it's a long string and looks like a result of a hash function. And it can be reproduced anytime from the original content. It can be reproduced anywhere in the network, in the IPFS network. These functions are actually upgradable. So the hash function that IPFS uses, within the protocol, there are things to describe what hash function it uses. So in case of like quantum computing taking over the world, we can still have secure systems because the protocol allows certain upgrades in this hash functions. So it turns IPFS turns content into Merkle DAG structure, so direct acyclic graphs. In this structure, each node, each level of the data has a content-based address. So you can identify or locate the content on every single level using the CID technology. A couple of really good features of this technology is that it deduplicates information really easily and natively. So let's say if we start a new folder on the side of user one folder, this new folder, if it contains the same information as same files as the old folder, then it will not actually duplicate the information. It will just refer to the folder with that content because it's essentially the same content. Because of this nature, we can also verify the content because if the content is changed even slightly, it will generate a new CID. So we can automatically verify and have this immutable content stored on the file system. So how does message get around in the network? It is done through content routing, and content routing is based on a technology called distributed hash table. So it's like using it's the best way to describe it is all the peers, all the people keeps a few pages of a phone book, and together by talking to each other a lot, it will create a network of full database or routing. So each node needs to be discoverable, and each node needs to be routable. Each node needs to consume services from each other. Each node will also need to provide services to each other. They will talk in secret languages, so they will have their communication encrypted, so it's private. But they also have unique IDs, so people can find it. So that's distributed. That's content routing, and this is what a distributed hash table kind of looks like and how it works. You can keep a lot of information in distributed hash table. In IPFS, there are two kinds of content that's being provided. One is where does the content live on which peer, and where can we find those peers. And it doesn't just limit to one single internet protocols. It can keep multiple protocols within the system, as you can see from the left. How do we use IPFS? Well, you can host the node yourself. You can actually download a desktop software and run IPFS software online yourself. And what you can also do is you can run a cluster of IPFS nodes to increase the availability and the redundancy of your content. But you can also pay some other people, like Infura and Pinata, to be able to pin your information on IPFS. What you can also do is you can use Filecoin to persist those data, but we'll talk about that a little bit later. But just using IPFS doesn't mean that your content will be there forever. Your URL link or the CID link will be there forever, but the availability of the files relies on the node that provides the services, right? So imagine in the BitTorrent system, if people stop uploading files, then that file is no longer available. So that means unpopular or the content that's not downloaded a lot of times will be harder to retrieve over time. So IPFS works similarly. What you can do is you can use Filecoin to solve this problem in a very affordable way, but we'll talk about that a little bit later. So this is what a IPFS node looks like. And as I said, there are desktop softwares available. There are also different versions of IPFS implementation that's done in Rust, in Go that you can download, and you can generate the bytecode to install to any system and have it running. IPFS also has npm packages that you can use. So JavaScript implementation of it, so you can run things like in the browser. There is a IPFS browser extension that you can spin up a node on the front end only, and then have it running in the background. IPFS is also integrated to popular browsers like Opera and Brave natively, so you can type in IPFS : / and then CID that will serve it natively. So I'll quickly show you. So this is actually the web dashboard of IPFS desktop client that I'm running right now on my computer. Notice that the URL points to my local computer. And this is showing that all of the information about my IPFS node. So how much data is coming in, how much data is going out, and those are the number of files that I have pinned. So this one, the file 3 is pinned on my computer, so it's constantly providing this to the network. If I want, I can explore the different CID data structures within. Right now, I'm connected to 618 peers, so mainly Australia, or some in China, in Japan, and in Singapore. So you can see that it's a swarm of computers, and nodes can come in and also leave anytime they like. I think the average number is about 10,000 nodes around the network online to serve this. So together, there is a incredible infrastructure to serve content peer-to-peer around the world. Another way to, so I talk about how to serve content with IPFS, and to read content from IPFS, you need to use one of these gateways, because you need to use one of these gateways. So we have built integration with certain browsers like Brave browser, where you can use IPFS directly. But for other browsers that is not compatible, you need to go through gateways that translates HTTP to IPFS. So there are not just one or two gateways available. There are many gateways available out there that is serving content. So that's primary way of people retrieving content from IPFS right now. IPFS, you can have hosted nodes. So if you don't want to pay for, if you don't want to run the computer system yourself, and it could be really labor intensive to run those things, what you can do is you can pay a few companies like Infura, Pinata, these kind of companies to host the IPFS and those for you. So they will look after the machine for you and give you services so you can talk to IPFS really easily. So what I have done earlier is I've logged into my Infura account, and I've created like an IPFS node very easily. So I just went to here, create. So what did I do before? So I think, yeah, so over here, IPFS, create new key. So type a blockchain week. So create service, and within just that was just a few seconds, I'm able to have my own private IPFS endpoint with my private API keys to talk to the server. For whoever is busy like noting down this, I'll be deleting my project right after this talk, so you don't have access to my private IPFS node. So through these endpoints and the API secret, what you can do is actually you can go to npm download IPFS HTTP client and incorporate this in your project. So you can put in your Infura ID token secret in the configuration, and then use very simple functions like creating a client, and then use client.add to add any piece of content to IPFS really easily. So this is how you use it in actual sort of project scenario. So this is a workshop, so I'll get you to do something. By now you have heard a lot about IPFS. So if you scan this QR code, you'll be led to a site that I have built that looks like what's on the right-hand side. So this is a demo software that I have created to show that how easy it is to use React and Web3 storage together to upload files in there. So if you scan this, you'll find a really simple site to upload files. And then after you have created those files, it will show you a link, and that is an IPFS link with CID on it, and you can retrieve that data very quickly. So this is actually the code. This is actually a slightly different software with Ethereum sort of integrated into it. So people will have to pay certain fees to be able to upload, and the downloader will have to pay a certain fee to be able to download those files. So this is my way of showing how a decentralized application can be built. And for this one, I've used Vue.js framework instead of React, along with Web3 storage, SDK. So this site, what's significant about this URL is it is deployed through a service called Fleek. And Fleek is a tool similar to Netlify, and it is fully integrated with IPFS and Filecoin. So if you build a site, connect your GitHub repo and ask Fleek to host it for you, it will be on Decentralize Web straight away. So the picture that you have sent, if you choose to use it, it has gone through the front end that's been built by me, and it talks to the Web3 storage through an API and its API key. And Web3 storage does not store it. It does have its own IPFS to pin it, but it relies on the Filecoin network to be able to persist this data. And when someone is trying to download it, it goes through IPFS gateway to retrieve this from IPFS for it. So that's what happened behind the scenes. So now on to the second part, which is the Filecoin part. Is there any reliable way to store things on IPFS? That's precisely the problem that Filecoin tries to solve. Filecoin is compatible with IPFS and compatible with other Web3 protocols like Near. It is verifiable. It's with cryptographic proof. So the storage providers or miners that we don't call them miner anymore because they're actually providing services, IT services to other people. So they will receive block rewards if they are doing the right thing, which is providing storage faithfully to other people, and they will get punished and slashed if they have done something wrong with the data their client asked them to look after. It gives you basically control over how permanent your data would like to be on Web3. It is it is the largest decentralized or distributed network for storage. It has achieved 16 exabyte of capacity across the globe, provided by thousands of storage providers. There were 4,000, and the number is still quite high these days. So it's governed by consensus. It's not owned by a single corporation, and it's community driven. And so this process called Filecoin improvement proposals. So anyone in the community can propose it, and we'll go through a governance process to decide the future for the network. So to be able to store something on Filecoin, what you need to do first is a client. Usually, a client is in a sense like a wholesale client. They have a lot of data that needs to be archived on Filecoin or stored on Filecoin. They will make a deal with storage providers, and storage providers will receive the deal, bid for price, so we can always keep the price low. There's dynamic competition going on between storage providers and the deals they can take. And then after they have won the deal, they will take the file and create a replication of it. They will take the data the client sent to them and create a replication of it. And the first thing that they have to send to the network is to prove that they have the content that their client wanted. And this is through the beauty of the Merkle DAG. They are turning their content into this publicly verifiable way, and then their storage providers is able to easily provide those proofs to them. And then from that point on, once the file is stored, from time to time, Filecoin storage providers will need to prove to the network that they still have those files. So they're sending messages to the network to show that they still have snippets of those files. If they can't provide those proofs, and they will be heavily slashed. So this is our way of providing enterprise level of services to clients. Towards the end of the storage deal, usually it's 6 months or 18 months, and that will change with the launch of the Filecoin virtual machine in the future. But right now it's a set time, and towards the end of the storage deal, the client will need to renew the deal or let it expire. And that means the client is not obligated to keep those files for the clients. There are two important designs that Filecoin made to allow permanence of the data. One is the deal. Filecoin deal can be renewed infinite number of times and can be done by anyone. So anyone who has interest of keeping the data for longer can go in and take over and make those deals. The second thing is there are thousands of storage providers out there around the globe. The client can choose to replicate their copies of data as many times as they want. So we really want resistancy. We really want permanency for the client's data. And using IPFS with Filecoin is a good combination because Filecoin IPFS doesn't restrict on the storage layer. So you can use cloud storage in parallel with Filecoin. That's definitely okay. So it provides more flexibility for people. So how do you connect to Filecoin? So Filecoin is a blockchain network. So with off-chain storage, so the data actually doesn't get stored on the chain, but the proof of storage, the transactions of Filecoin stores on chain, and to be able to access those transactions, you need Filecoin's node implementation softwares. So there are three right now. Lotus is a dominant one. There's about 4,000 users of it. Venus has about 50 users. So Lotus is maintained by Protocol Labs, and then Venus is done by a community company called IPFS Forest, and Forest is something that Protocol Labs has commissioned, and Protocol Labs and Filecoin Foundation has commissioned ChainSafe to build a Rust implementation of our node. It's called Forest. So there are 3 kind of available right now, and they're designed for Filecoin network operators and node operators who just wants to create a blockchain, and for developers who are building storage markets, tooling, applications on top of Lotus and Venus. So this is how you access to Filecoin. IPFS and Filecoin provides a really good storage solution for developers because IPFS is for fast and flexible retrieval. So it is good for hot storage. And then Filecoin is for persistency and verifiability. So that is perfect for cold storage or archival storage. So this is a developer bootcamp. So I'm going to provide you with some dev tools that you can go back to and use in your project. One of the ones that I've just talked about was Fleek. So Fleek allows fast and modern censorship-proof websites to be done very easily. All you have to do is actually connect your GitHub repository or other repository that you would like to use, sign in and then do it. You can create websites for free. Today, if you want to, in a few minutes time, it will build and then deploy your website on IPFS and Filecoin. So it's incredibly easy to use. I've used it numerous times in different workshops. NFT storage is a storage service that we have built. It is like the Dropbox for NFTs. And right now there's about 100 million NFT objects stored on NFT.storage. It's a free service that we provide to NFT industry, free forever. So anyone who's building an NFT project, please have a try of NFT storage. They have really incredible systems to build it. Actually, let me show you very quickly. So these are like the backend of NFT storage. These are files that I have uploaded, and these are actually Filecoin storage providers who are persisting my data. So for example, this picture of Bender here, that is being persisted by these 2 storage providers, and I can probably look up their information from here. Yeah, so that's a collateral hold against my specific sector here. So these NFT storage has incredible tools. They have JavaScript libraries so that you can include in your project very easily. But they also have, for non-coders, they have NFT app, which is a desktop software that you can install, where you can drag and drop all of your NFT assets and batch create all the CIDs that you want. So those CIDs will eventually get written into smart contract in the blockchain of your choice. So you can batch mint this very easily for projects. So for example, like 10,000 NFTs, you can drag the files in there. It will generate all of the immutable content. Don't put it on Dropbox or Google. Don't use Dropbox links or Google links because they are Google Drive links because they're intrinsically centralized, and it doesn't contain any information about what it is. But if you use IPFS for your NFT project, it tells you what file you are. So your user or your buyer will know exactly what they have bought. So NFT storage intends to provide really easy services for people to use. So look it up. And Web3 storage is more of a traditional, like, pay-as-you-go kind of service. So you pay monthly fees to this service, and it provides storage for you. So Web3 storage, this is what the backend looks like. I have a lot of files stored in here, and I've only used 1.6 gigabytes through all of the demos. So you can view those files really easily. And then let me just take a look at this. Yeah. So you can retrieve it very quickly as well. So over here, yeah. So there is some MP3 that, that's being uploaded by someone. So the JavaScript client library is quite handy. I use it all the time in my project. So the software that I've shown you here, so it's made by Vue.js and Web3 storage. So if I go to the source code, components, and file uploader, so you'll find relevant code related to Web3 storage. So I've imported Web3 storage SDK there. And then over here, I instantiated the Web3 storage client with my API token. And then over here, a bunch of things related to spinning up the Ethereum environment. And then over here, this single line of code actually puts the file that user used to upload to my Web3 storage account over here. But once it's gone through the Web3 storage service, it's onto IPFS, and it's being persisted on Filecoin storage providers. This is one of the other applications of Web3 storage. Over Web Summit 2022, which was last month, the event that I met Manny from Polygon. We have built a photo booth. The events team built a photo booth, and I built the integration between this photo booth and Web3 storage through a Node application. Very simple Node application. It just relays APIs from the photo booth software to Web3 storage, and it uploads the selfie that people have taken to Web3 storage. So the one on the right, this lady is actually from CNN. She interviewed this photo booth. I don't think she fully understands the technology behind it, but she says she wants to shoot something about Web3. Over 3 days there were 590 photos uploaded to Web3 storage. So the system works, and it is our demonstration of how easy it is to use our services and integrate with different kind of devices. There's also S3, which is a technology that allows developers to have a deeper interaction with Filecoin protocol. So what that means is actually, apart from storing information, apart from just storing and paying for storage, like all the convenient storage services that I mentioned earlier, what you can do is you can use through S3, you can manage those deals. You can have very easy graphic interfaces, or just have servers spun up on your side to be able to provide, to be able to fine tune the deals that you made to different storage providers. S3 actually is a boilerplate, S3.txt actually boilerplate software, and that is open source for developers to copy. So you can, if you want, you can make your own like Web3 storage and NFT storage and charge fees for it. So a lot of our storage providers, they do take Filecoin deals like raw, but what they also do on the side is they actually use S3 technology to be able to provide cloud storage like NFT storage and Web3 storage, and charge a subscription fee on top of it. So it's incredibly, it's a little bit deeper. It's a lot deeper than you just using an API call to send your file over, but I highly encourage you to take a look at the source code they have there. OrbitDB is a project that intends to solve the distributed database problem. It is one of the projects that's being funded by Filecoin and Protocol Labs, and it's getting there. So what we have done is we would like to provide the storage, and we do that through the help of the storage helpers. So NFT storage, S3 that I talk about, Pinata pins information on IPFS, and then Web3 storage also interact with IPFS and Filecoin. We're trying to solve that problem. For the logic layer, you will need to go to other chains like Avalanche, Polygon, and Solana. What we're slowly building is Filecoin virtual machine. Actually, it's in testnet right now. In next year, Filecoin Ethereum virtual machine compatible one will be launched in February. So we're trying to solve the logic layer now that we have solved the storage helper, storage layer. So Filecoin virtual machine is going to produce a lot of good things for developers and allow us to be able to participate in the higher layer of the architecture in Web3. So some use cases we have The IPFS and Filecoin is being used by many projects. These are just a few that we showcase from time to time. I encourage you to explore Filecoin's ecosystem and find out how other projects are using it in order to get some inspiration for your own project. There are some very important customers of Filecoin. Internet Archive is an organization that is using Filecoin to back up their data. Starting Lab is working on a few initiatives, including recording Holocaust survivors' testimonials to Filecoin. And we have a project called Huddle01 that is using IPFS technology heavily to build a peer-to-peer video meeting service. Audius is the Spotify for Web3, and they're using IPFS to store the music files. LivePeer does videos, and OpenSea uses NFT.storage to be able to provide IPFS services. And what's really cool is New York City open data is stored on Filecoin as well, so it's in the hands of the community. What's coming up next? Filecoin virtual machine, as I mentioned earlier, is going to unlock Filecoin from just providing storage. So we're adding smart contract or custom actors that we call it in Filecoin virtual machine, and we're going to allow things like layer 2 DeFi, maybe in the future NFT projects to be built on top of Filecoin chain. If you're interested, they're right now having early builder programs, and they're running hackathons on their testnet. So feel free to have a try and provide feedback. And if you have some good ideas like building an SDK for FEM, feel free to contact them, and also go to our grants program to be able to receive some funding for your project. It's a great project to watch. Another really big project is solving the problem of distributed CDN. So I spoke a lot about uploading files to the system, getting information out of the file system. Right now it's not very efficient, so you need to rely on retrieval deals. Retrieval.market is a project that is intending to automate that process and make a decentralized version of CDN, so we can serve those data in a very automated way, very scalable way. They have just launched their Saturn network not long ago, so last month in Lisbon as well. So what Saturn does is it will allow, so I'll show you very quickly, it will allow normal folks like you and I to provide computing resources and then provide content in our local region in order to earn some Filecoin reward. Now, it is true that you can set up a node in 5 minutes really quickly. I actually did this during the launch presentation that they have. So within like 15 minutes, I was able to get it up and running. But they're still working on the reward mechanism, so people can be paid for it. There is quite a bit of requirements on the network bandwidth, 10 gigabit per second, which is quite a lot, and normal household users can't really achieve those. But it is there trying to solve the bandwidth problem for downloading. So there's a lot of reason why they have chosen such a high bandwidth requirement for the miners. Or for Citizen network. So check out this project. It looks very promising, and it's going to solve the retrieval issue that Filecoin has. So there's not just one Saturn network. It is one of the first that's been launched. Retrieval.market is actually funding several decentralized CDN projects right now in order to have several solutions going in parallel. We will see which one will succeed. So this is my presentation. This is it. Yeah, we're getting to the end of it, and I have like 2 minutes to spare. Get in touch with us. We have an incredible community run on Slack. We also have Discord, but it's we started on Slack, so Slack is the dominant place for a community to hang out. As a developer advocate, I host office hours every Friday your time, so pretty much my time, and then anyone can join our office hours to chat to us about tech or anything related to Filecoin IPFS or not. If you don't want to talk about it, that's okay. We're cool about it. There are heaps of videos that you can watch. There are newsletters for IPFS and Filecoin respectively. We're on Twitter. We're big on Twitter as well. And then for this bootcamp specifically, if you need help from me, I'll be around. So scan the QR code on the right. This is my link tree. So if you go down to the bottom, or if you just scroll to the middle, you'll find all of my DM methods: WhatsApp, Telegram, whatever you want to use. Feel free to reach out to me, LinkedIn if you want, and then you can arrange meeting with me if you don't want to talk about your project openly. Well, thank you very much for the opportunity to speak at Taipei Blockchain Week Developer Bootcamp. I wish you all the best to your project. If you need help, let me know. Happy to help.